All right. So we're going to divide two multi-digit whole numbers. But before we get started, we first want to know the vocabulary. So division you'll see actually in three different ways. These are the two most common ways, but another way that you'll see division is you'll have as a fraction like this. These are the three ways that you will see division. So to do division, it's important to know the vocabulary, and there's three vocabulary words. So for this strategy, right, this is called the divisor. This is called the dividend. Now when you get the answer, it's called the quotient. And the same will be over here. So the 12 is still the divisor. Here we have the dividend. And then the answer will always be called the quotient. And then finally with the fraction, the top number, which in fraction we call a numerator, but when it comes to division, this is still the dividend. And the bottom one is the divisor. And of course, the answer will always be quotient. So these are just three different ways that you will see division, starting from this year till years in high school and possibly in college as well. Now, there are going to be three strategies that we're going to do. We're going to use this expression first, using standard algorithm. So standard algorithm is the normal way that you will see in the US. And that's this one right here. So I have, just rewriting the expression, 996 and 12. Now for all these strategies, these three, what I teach students year after year is to understand their multiples of each factor. So in this case, we have 12 as our divisor, and we want to make a list of multiples of 12. So you're just counting by 12s, right? So you would say 12, 24, 36, 48, 60, we have 72, 84, 96. So 1, 2, 3, 4, 5, 6, 7, 8. And I can even do one more, which would be 108. So to use this strategy, you're going to see how many times the divisor goes into the dividend digit by digit. So you start with the digit that's up front. Now here, can 12 go into 9? Is there enough space? No. So the only digit we can use is 0. 0. We subtract to get the difference, so we have 9. Bring down the next digit, 9. Now we have 99 down here. Now can 12 go into 99? Is there a number on this list that's close to 99? What number do you see? 96, right here. 96, this one will work. 96. Now how many times did I have to go down the list? 1, 2, 3, 4, 5, 6, 7, 8. 8 times. Alright. I subtract the difference here. 9 minus 6 is 3. Bring down the last digit, which is 6. Now, can 12 go into 36 according to this list?
Yeah.
Is there an exact number?
Yeah.
How many times did I go down the list to get to 36? 3 times. Now, there's no more numbers to bring down, so this is absolute 0. And now my quotient here is 83. So this is the standard way. Meaning this is the most popular way that you'll see it being used. But most times, I've known teachers that don't do the list of multiples. But if you have the list of multiples, you know exactly what numbers to plug in there. Okay? So this is strategy 1. Now I'm going to show you another one called the box method. We're going to use the same expression, but we just want to use different strategies to prove that it does work because we end up with the same quotient. So for the box method, we're going to make a rectangular box about this size. I'm still going to put the 12, the divisor, outside. But here, my dividend, we had 3 digits. So I'm going to make 3 boxes inside my rectangle. And each of those digits, I'm going to put them closest to the right. 9, 9, 6. Now, it's pretty much the same thing as this one, but you'll notice that for standard algorithm, we went vertically down. We're going down. For this one, we're going to go to the right. So it's just a different direction you're taking. So here, what's helpful is because you just see the number 1 by 1. You don't get yourself confused because here, every year, the students bring down their numbers and they somehow, it starts curving to the side. So this kind of helps that with students who have trouble with that. So here I ask myself the same questions. I can use this list of multiples. Can 12 go into 9? We know there's not enough space, so we only say, well, no, we can't. So there's 9. Well, now I have this leftover 9, and it's actually going to go in front of the other 9, 99. Now we know that 12 can get close to 99. Its multiple, we know, is 96. And we used it 8 times. And that gives me 3 left over. So you can see that it's exactly the same steps. We're just moving in a different direction. And then I have a leftover dividend, so I move it in front of the other one. So now I have 36. And we know that 12 can go exactly into 36 3 times. And then that gives you 0. So you can see that we still matched the quotient from the standard and the box method. So this is strategy 2. Then there's one last strategy, and I think you guys might be familiar with it. And I know that some teachers, or even myself, we like to call it the Big 7. And I'll show you, it looks kind of like this one, but it's a bit of a different approach. So I'm going to zoom out and move this upward. And this is the last one. It's called the Big 7. So what it is, it's you start like the standard algorithm, 9, 9, 6. And you put the 12. So it looks like that, but we're going to make it look like a giant 7. So this little bridge that we have, we go straight down like this. Kind of like a giant 7. Now, the strategy to this Big 7 is you're taking big chunks. You're kind of biting off big chunks out of the dividend. Okay? Now I have to ask myself to take big chunks, and by taking big chunks, I always think of numbers like 5 or 10 or 20 or 50. Those big chunks that have zeros are always helpful numbers. So I'll show you what I mean. So I have to find a number that I'm comfortable with, that I can take a chunk out of 996. So a big chunk that I can think of is, I say, well, what's 12 times 10? Well, 12 times 1 is 12, and then there's a 0, so I can put it at the end, so 120, right?
Yeah.
So I can take a big bite by using 10, and that gives me 120. So I can take a piece of the whole, right? So now I'm going to subtract it. I have 6. I have here subtract, we have 7, and I have 8. So I say, okay, we took a big chunk, but we actually still have a lot, right? So should I use 10 again, or should I think of a bigger number?
Bigger number.
Okay, let's try to use numbers that have 0 in it. So there's 10, 20, 30. Give me a suggestion. What do you think? 30. So we're going to use 12 times 30. Well, when I multiply that, 12 times 3 is 36. There's a 0 that carries over to the product, so 360. You know what? That number I can put. So I'm going to use 30, and I'm going to take the 360 out of that chunk of the dividend. So now I have 6, I have 1, and I have 5. So that worked. That took a very big chunk out of this. Now, should I use a different number, or should we use 30 again?
Different number.
So give me a suggestion. Do you think 40? Well, let's try 40. So right now we're at 516, so say 40. Well, 12 times 4 is 48, and then the 0 carries over to the product, so 480. That'll work. We're still under, so we can say, okay, another 40, and that's 480. That's going to take a major chunk of the dividend. So that would be 6. Here we have 1 minus 8. We'll regroup. Now that's 9, 10, 11. That's 36. Wow, so now we went from the hundreds, now it's just 36, right? Now, from here, it makes it very simple. Can 12 go into 36?
Yeah.
Yeah, we can see from our previous list of multiples, 3 times exactly. And that will eliminate the 36, and then there's no more, right? But then where's the answer? Well, all you have to do is add up these guys outside of the big 7. So if I were to add them, here in the ones place, I have 3. This is 4, 5, 6, 7, 8, 83. So you can see that for all 3 strategies, we ended up with the same quotient. They look different. We kind of took a different path, right? But we all ended up in the same quotients.